Hello students, good evening all of you. Yeah, this is Annie Rao, founder director of VIP classes. Okay, so let us have today discussion on numericals and laws of motion plus friction. Okay, one basic video already we have made students regarding laws of motion, friction, entire revision I have done. So let's take some few numericals here. Okay, yeah, let us enter into this numericals now. So first question is see here. Which of the following physical quantity is not a vector quantity? You know, vectors are those physical quantities which have both magnitude as well as direction, right? So here force has both magnitude direction, right? So you can say force is a vector quantity. So pressure, there is no specific direction for pressure. We have seen is tensor physical quantity said, right? So now coming for momentum has both magnitude and direction. So velocity also direction. So only the quantity which is not having what? Direction, specific no direction. In all direction it acts actually, so we can't define specific direction. So pressure is a scalar, you can say, or your level, and higher level we can call it also as what? Tensor physical quantity. We have said stress and this, isn't it? Right. Therefore, so out of these given physical quantities you can say pressure is what? Is not a vector quantity. Fine, this is the answer. Force has direction, momentum has direction and magnitude, so velocity also what has magnitude and direction. So all these are what physical quantities these are vectors. Okay, right. Now coming for second question is see all of you, two forces are acting on a body placed on a smooth horizontal surface. So the acceleration produced in the body, what is the formula for acceleration, everybody? So acceleration is net force acting on a body by total mass of the system, you can say, or net force acting on a system by total mass of the system. See here, one force is 10 Newton acting like this, 100 Newton like this. So what is net force here? So net force vector sum, when two vectors are in the opposite direction, we subtract their magnitude. So 100 minus 10 Newton, so which will be how much? 90 Newton is the net force. So net force is 90 Newton by total mass of the system is only 2 kg block is there. So 90 by 2 how much? That is 45 meter per second square. So this is the answer for the question. Okay, so option C is right. Clear? Now next you can see. Choose the correct statement according to Newton's laws of motion. Okay, inertia of a body is proportional to mass of the body, right? In linear inertia we have spoken already. So more is the mass, more is the inertia. Mass is the measure of inertia. So right statement. Action and reaction are pair forces and they act on different bodies. Yes, obviously. So because of which we are not cancelling them. For example, you are throwing a ball towards a wall. Action is on the wall. Reaction is on the ball. They're acting on different bodies. That's why we won't cancel them. So action, reaction, pair of forces and they act on different bodies. Right statement. If no net force acts on a body, body does not move. When no net force acts on a body, okay, the body does not move. So here statement you can say when no net force acts means what? Acceleration is equal to 0. Fine. When acceleration is 0, so velocity may be constant or velocity may be 0, students. Okay. So acceleration means velocity is here constant. Body may move with uniform velocity. Okay, the body does not move, is saying, isn't it? So possible is that if no body is at, for example, you are having a block on the surface of earth, for example. So here normal reaction acting upward and weight acting downward. Here net force 0, body not moving. So in one sense the statement is correct only. So you can tick here all the above statement. Okay, right. Now next you can see a force is acting on a body of mass 5 kg as shown. The net force is, see, a force acting on a body of mass 5 kg. The force acting on the body is saying upward, downward and all, right? So if you say mass of this body as 5 kg, if you are lifting away from the earth, if you assume here, okay. So if you draw the FBD, the force is acting on the body. One is 100 Newton, you are acting upward. Its weight is 50 Newton acting upward, so downward, sorry. So net force will be upward direction. So 100 minus 50 is the net force. How much will be equal to? So 50 Newton. In what direction? In direction of larger magnitude. So 50 Newton upward, you can see. Clear? Right. So next you can see, students, if no force acting on a body is 0, which of the following statements may be true, he is asking. Body is at rest. Net force, and just now we have seen, yes, the body may be at rest, you can say. Body moves with constant speed in straight line. Yeah. So speed in a particular direction is velocity. Body may move with constant velocities. Before example we have seen when acceleration is 0, velocity is constant. Momentum of body is constant. Yeah. When net force is 0, acceleration 0, velocity is constant. So body may move with constant momentum. That's true. So all the above is the right answer. Hope this statement is clear. Yeah. Now coming for two forces are acting on a body at rest as shown. To net force, the body acquires a constant acceleration. The velocity of the body at the end of 2 seconds is saying. See here, two forces are acting. No, one is due left, another is due right, student. Okay. So if you see here, the net force will be 120 to the right direction. 20 is opposite, so minus 20. How much will get here? 100 Newton. And mass of the body, how much given, students? That is equal to 2 kg. So what the acceleration of the body will be? So acceleration by Newton's second law of motion, force, net force by mass, that is 100 Newton by 2 kg. How much will get? That is 50 meter per second square is acceleration. What is asking? Velocity of the body at the end of 2 seconds. So we have seen velocity after t second when acceleration is constant. When acceleration is constant, so what you can say? Velocity of the body is equal to u plus at. So at rest he is saying, so initial velocity will be 0, acceleration is 50 in how many seconds? 2 seconds. So 50 into 2, how much will have? That is 100 meter per second. Clear? Now coming for next question, you see the SI unit of a physical quantity is the product of force and time. Yeah, we have seen the force and time graph I mentioned in the revision class. You can see laws of motion behind formula series. Okay, now so force and time graph if you draw. Okay, so force and time graph, anyway it may be fine. So it gives impulse, we said, or change in momentum, we have said, right? So if you multiply the physical quantity force into time, we are getting change in momentum, or we can also call it as what? Impulse. So unit is momentum, unit is kilogram meter per second. SI unit of physical quantity, product of force and time. Okay, so kilogram meter per second. C is the right answer. Now student, now you can see a ball of mass 200 gram is dropped from a height of how much? G by 2 meters onto a surface. So the ball rebounds to the same level. So ball is rebounds. You see you are dropping a ball of how much mass? So 200 grams. That means 0.2 kg. So from what height you are dropping this one, student? So you are dropping from a height of h is equal to G by 2. Okay, G by 2 height. G by 2 meters. Fine. Now velocity ball just before reaching the ground. We have seen velocity of a body, freely falling body. Okay, before reaching ground formula, what we discussed? Root 2 GH. So root of 2 into, so G we can take as G, H value will be here G by 2. So we get cancel. So root of G square means how much, right? Root of G square means we'll have G meter per second. Velocity of the body before hitting the ground. G, we can take 9.8 meters here. So you can say magnitude of G equal to, okay? And the change in velocity of the body after hitting the surface. If the ball rebounds to the same level, there is no loss of energy. And we have mentioned also this kind of collision is called elastic collision. Okay, yeah, when the body is bouncing back to the same level, student, over here, fine, when the body bounces back to the same level, so what you can write here, fine. So change moment. So initial downward if you take as positive, upward becomes what here? Negative. So it's asking change in momentum, change in velocity. So what is change in velocity formula? Change in velocity is final velocity minus initial velocity. So finally upward, so it is negative and there is no loss with same magnitude is going. That is how much? G meter per second. So you can say upward, so minus G minus initial downward, it is initial downward means what? Positive, that is equal G, which is equal to minus 2G meter per second. This is change in velocity. Okay, and then the collision time, the time for which the ball in contact with the surface is 1 millisecond. Okay, the force exerted by ball on surface. So as we have seen Newton's second law, force acting on a body's formula is what? Rate of change of its momentum. So average force exerted delta P by delta T. So change in velocity we know. So you can find out change in momentum is mass into change in velocity. So mass of the body, how much given here? 200 grams means 0.2 kg. So you can say this is 0.2 into, this is minus 2g. So 2 into, if you wish, you can take here value in the bracket for simplification. Say g value 10 meter per second square. So you can write down 2g, so this is 10. So this becomes now, decimal get cancelled. So this is minus 4 kilogram meter per second. So when the ball is falling down here, so change in momentum is upward. So force direction also in the direction of change in momentum, it will be upward, students. Okay, so minus 4 kilogram meter per second by time duration in contact is 10 power minus 3 seconds he is saying. So you can find it out as, so here minus 4 into 10 power 3 kilogram meter per second square. This will be Newton. So you can say minus 4, you can say kilonewton, or 4000 Newton. So here minus indicates that force is in what direction? Upward direction. Why upward? We assume upward as negative. Okay, right. Now this is the answer for this question. You can fill in the blanks. Okay, like descriptive type you can assume. Now coming next question here. Two unlike forces are acting on a body as shown. So 3 Newton, 21 Newton. The acceleration produced in the body. Already we have seen. So acceleration is formula what you said. Net force acting by total mass of the system. So 21 Newton minus 3 Newton divided by mass 3. This will be how much? 18 by 3, which will is equal to 3 6, right? So this will be 6 meter per second square. Acceleration. Velocity of the body is 18 after a certain time. Value of time is asking. So velocity after t seconds formula we wrote already in one dimensional motion, u plus at. So velocity of the body is 18. Okay, so body is starting from rest. Okay, so not mention anything. So you can say 0 plus a value is 6 into some time t. So from this you can find time t as how much? 3 seconds. Okay, right. Now coming for a block of mass mkg is suspended by a spring balance as shown. The spring balance reads 200 Newton. The mass of the block is saying. So as you have seen spring forces. So when the block tries to pull the length of the spring like this. So restoring force developed will act like what? In this way. That is kx. So that when in equilibrium, what happens? If you draw the FBD of this one, forces acting on this body, what happens? Mg will be acting downward and kx will be acting upward. So theory you can see I discussed in laws of motion beyond formula series. Okay, so in equilibrium you can say kx will be equal to mg. Student, they are asking the mass of the block if the spring balance reaches 200 newtons, right? So reading of the balance r is equal to kx is 200. So 200 is equal to mass into g, you can take as 10. So you can read this one as the spring balance mass is 20 kg. Okay, so 20 kg, and it is immersed in a liquid of densities. The weight of the liquid displaced is 10 newtons. So then what is asking? If it is immersed in a liquid of density, the weight of the liquid displaced is 10 newtons. So then you can find out here if it is immersed in a block. For example, this block is immersed in a fluid. Okay, here when I am pasting something this data here, let us understand, no issue. So weight of liquid displaced we call as buoyant force. Students, remember again in fluids we'll talk. Okay, and actually its weight how much? 20 kilogram weight. So 20 kilogram means 20 into g, right? So 200 newtons. The question might be what is his now new reading, you can say. So now new reading how much? Now you can see when 200 Newton downward should act, but decreasing by a factor of 10 Newton. So now correct new reading r dash will be, so 200 minus opposing force of this water is 10 Newton. So which will how much? That is 190 Newton. So it decreases. So a body appears to lose its weight in water. That is called apparent loss in weight. Okay. So this is how we have to attempt the questions. Fine, all of you? Yeah, students. So thank you all. So once again, go to this kind of model questions. So we have just summarizing this video now. We can see I just discussed about basic what are vectors and scalars. Okay, one definition, then net force concept and finding acceleration. Next we have found what is the net force when acting on the body, how the body will move based on Newton's second law of motion, and then force acting on the body we have seen net force concept we discuss. Okay, just basic Newton's second law of motion, and net force acting on the body, movement of the body constant or not, all those things we discuss. And here again acceleration, velocity after t seconds we have discussed. Okay, and f of force and time graph gives what? Area under force and time graph gives momentum or change in momentum, which we call as impulse. Okay, and then body bouncing back, exact application of the second law I have discussed. So force will be the direction of change in momentum. So downward we have taken positive, so upward will be what? Negative. So force will be also be on the ball will be upward direction. So net force we found, change in momentum we found, very important model for competitive point of view also. That's what you can call impulsive force, or change in momentum is called impulse. Okay, and here same again net force formula, acceleration, velocity model we seen, and in spring balance reading, spring balance, okay, actually what it measures as the force acting on it. So downward mg is acting, kx is upward. In equilibrium kx is equal to mg, we found the mass. When you immerse in water, what happens? It appears to lose the weight. Same thing when you jump in swimming pool, what happens? You appears to what? The water appears to pull you upward, right? Push you upward, right? So your weight appears to decrease. That is called apparent loss in weight. Okay, that is net weight is equal to 190 Newton, loss is 10 Newtons. Okay, so like this you can focus this kind of numerical, student. Fine. So thank you all. Please subscribe this channel and share with among your friends, and please post the comments. Okay, and ask the doubts also. So thank you all. Fine. We'll meet in next series again with numericals. Okay. Thank you all.